Hey guys. Okay, so this is a problem similar to one of the problems on the second page, the back page of Energy 3. And what it wants us to do is figure out what kind of conservation of energy equation do we have going on. So what kind of energy is happening, what kind of work is being done, and what kind of energy do we end up with at the end. So here we have an 8 kilogram object and it's moving 3 meters per second, so we have kinetic energy going on there. It doesn't say it's off the ground, so we're assuming there's no potential because of height, but it's pushed by a 10 Newton force for 7 meters. How fast is it going afterwards? Alright, so it has a kinetic energy afterwards. So the conservation of energy equation, actually let's do A first. Energy before is definitely kinetic, and the work being done, there's definitely work being done, and it's going to be positive. And work is equal to force, which there's a 10 Newton force, times distance, and there's a 7 meter distance, so we'll calculate that later. And then energy afterwards. How fast is it going afterwards? So it has a velocity afterwards, so it has kinetic energy, and we're going to figure that out. So the conservation of energy equation is going to be Ke plus work equals the kinetic energy afterwards. And since it's positive work, we're going to have more kinetic energy here than we did to begin with. So we're going to plug in what we know the equations are for kinetic energy and for work. So here, and I'll change colors real quick. Kinetic energy is 1/2 mass times velocity squared. And then we have plus work, which is a force times the distance. And that equals the kinetic energy afterwards, which is 1/2 mass velocity squared. Okay, so how we're going to solve for this is we're going to plug in the numbers that we have, and we're going to solve for how fast it's going afterwards. This v squared over here is what we're trying to figure out. Okay, so 1/2, and our mass is 8 kilograms, times velocity squared. It's going 3 meters per second at the beginning, so that's 3 squared, plus force times distance, there's a 10 Newton force, times a 7 meter distance, and that's going to equal 1/2 the mass, which is 8, times the velocity squared afterwards. Alright, so we're going to multiply these all out. 3 squared is actually 9, and 9 times 8 is 72, and half of 72 is 36. We'll go ahead and double check that in the calculator. So 1/2, which is the same as 0.5, times 8 times 3 squared equals 36. Perfect. So we will write 36 plus 10 times 7. 10 times 7 is 70, equals 1/2 of 8, which is equal to 4. 1/2 of 8 is 4, v squared. Alright, so 36 plus 70, 36 plus 70 is 106. So we end up with 106 equals 4v squared. So the next step that we have to take to solving for velocity is divide both sides by 4. This right side cancels out. 106 divided by 4 is 26.5. So v squared equals 26.5. And then we have to take the square root of both of those in order to find our velocity. So the square root of 26.5 is 5.1478. So we'll say 5.1. So our velocity is equal to 5.1 meters per second. Okay. And then last question asks, if the force pushed for 5 seconds how much power was used to speed up the object? Alright, well we know that power is work over time, and it says right here our time is 5 seconds. And we know that work is equal to a force times the distance. Here's our force times the distance. So we know that 10 times 7 over 5 seconds equals 70 over 5, which is equal to 14. So we have 14, and what are the units for power? We've got watts. So 14 watts of power.